So in the last video we looked at relative addressing, and that was a really nice way of just taking a value, right clicking on the bottom square, pulling that down, then telling fill series, and we get those numbers. We can then, relative addressing was the case of using that cell reference, carrying out a calculation, and then pulling that calculation down using autofill again, and in this case it's altering the cell reference and relative to where you started from. By the way, I did want to point out one really nice thing about that series fill and with this calculation fill. So I could put a 1 there, and I can then tell the series, select that column, go to the fill statement up here and go to series, and I can just simply leave it as it is. Go down the column, use the linear progression, add 1 every time, click OK, and that's filled that number all the way down. If I then take this and I put equals that cell multiplied by 5, for example, I can then take that and simply tell it to fill down, and you can see my computer's busily trying to work that out, and then that runs all the way down. So how far does that go? Well, I told you there's 1 million cells, so how can I prove that? Well, I could scroll down. That's going to take a very long time. One way of doing that is to hold down the control key and push the down arrow key, and that's taken us straight to the bottom. 1,048,576. There are now no more cells, and it's done the calculation all the way down. So I can fill this, and the fill series will give me that long number of numbers. Equally, if I want to go back to the top, control and the up arrow pushes me back up to the top. Now that's a little aside, it's a nice thing to have. Let's just clear those because that takes my computer some time to calculate. So we've looked at relative addressing, and we just used relative addressing to do that relative, and what it did was fill series down that relative addressing. That's excellent. So let's say that I wanted to take the number 4 and I want to multiply it, but by each of these numbers I put along here. Well, that's easy. I go to this cell here, I tell it I want to do a calculation, equals, I say take this number here and I want to multiply it by this number here. Now obviously that's going to do 4 times 4, which is 16. So when I pull that across, relative addressing is then going to ignore the 4 and instead use the 6, and then the 7, then the 3, then the 4, then the 2. So what we should get here is 6 times 4. Well, 6 times 4 is 24, and then 7 times 4, which gives me 28, and 3 times 4, which is 12, and 4 times 4, which is 16, and 2 times 4, which is 8. So let's see how we do. I'm going to pull that across. Now, without even knowing the maths, I know, for example, that 2 times 4 is not 16,128. I know that 4 times 6 is not 96. None of these are correct. Something has gone wrong. I'm going to check on my first formula. Yeah, that's correct. I wanted to do this 4 times this 4. So in the next cell, I want to do this 6 times this 4. So let's see if I got there. Notice I am using the 6. The relative addressing has worked correctly to go this way, but I'm not using the 4. And if we think about it, that makes sense. The computer has used relative addressing. So as I pull it this way, not only has it changed the cell reference by 1 each time, but it's also changed the cell reference by 1 here. So it's moved the cell reference from H3 to I3, but equally from G4 to H4. So it's gone from those two cells to those two cells. That's a problem with relative addressing. I didn't want this one to change. I wanted it to stay looking at that. So a really quick fix to that is go to this blue box and drag it and put it where I want it. That's a really nice little trick. You didn't see that before. And now that works. And these numbers have changed, but that's because they're all looking at this cell. This one is now looking at this cell. So now what I've got to do is drag this and put it there, and now that one's correct, but these and now imagine if I've been doing that with one of those long series. I'm going to put a number 4 there, and I'm going to put a calculation in there that says this multiplied by this. Now what I'm then going to do is I'm going to replicate this all the way down as we did before. So go to series, fill it all the way down. I've got that 1 million now numbers, and what I'm now going to do is take this one and tell this one just to fill down, and now what that's doing is it's taking 1 times 4, then 2 times 4, then 3 times... No, it's not, because that relative addressing. I wanted this cell to always look at this 4, not come down. So I've now got to, that's when you're clicking in the wrong place, go to there, pull that up, and I've got to do that for 1 million cells. I'm not doing that. That's just not happening. Surely there's a fix to this, and there is. Let's go back. Remember, with computer science, we are all about being lazy. So what I'm going to do, in fact, what I'm going to do is I'm going to undo that. That's going to put the numbers back I've got there. Then I'm going to undo. So keep clicking undo, and those have gone. That's really nice. I'm going to go back to this cell in a moment, but let's now get rid of these. And let's look at this formula here. Remember, we're trying to be lazy. We want to type one formula and get all of the answers to work when we do an autofill. So we're looking at G4. We don't want this cell to change. What part of it do we not want to change? Well, we don't want it. When we put it this way, it's going to go from G to H. Let's just look at that again. This is G4. Now it's H4. The 4 has stayed consistent. It's still 4. But the column reference has gone from G to H. And that's what we don't want to have change. So what we do, we go to the front of there, just before the part we don't want to have change, and we put a dollar symbol. Now when I drag that across, it works. And if I click on there, we can see that says G4 with a dollar, and that says G4 with a dollar, and that says G4 with a dollar, and so on, all the way to the end. Similarly here, if I do equals this multiplied by this, but then I go just before the 1 because it's going to be R1, then R2, then R3. So it's not the column reference that changes here, it's the row reference that changes here. So I'm going to lock that row reference by putting the dollar in front of it. So think of the dollar as saying lock that column or lock that row. Here we're locking in that specific row, row number 1. The R can change. It's not going to, because we're not pulling it that way. But the R can change if it really wanted to. We're controlling that 1. So I'm going to press there. We still get 4. I can now go to here. I can now tell it to do a series fill. Click on OK. We now have our 1 million numbers. I can then go to here, tell it to fill downwards. And as we can see, it's now filled those all in. You might notice a bit of a jump. That's because that took my computer a long time to calculate all of those values. And I certainly don't want to do that again. but it's now doing 4 times all of those numbers. If we do a jump to the bottom, hold down the control key and press the down arrow, we can find out that 4 times 1,048,576 is 4,194,304. There's some useful information for you. So back to the top. To help my computer keep running, I'm going to get rid of those by just selecting them and deleting them. And we'll go back to this example here. This dollar locks that part of the formula in place, that part of the cell reference in place. In this case, the column reference. If I put a dollar next to the 4, just this side of the 4 to the left of the 4, I will lock in the row reference. And there's a really nice little calculation, nice little exercise you can do. And there's a really nice little trick we can do if we wanted to work on that quite nicely. I'm just going to show it with a very simple number. Equals that. There's nothing wrong with having a cell reference one piece of data. We can do that quite often. There's good reasons for that, but we'll look at that later on. For now, we've got that. So what I can do is press the F4 key. This is the set of keys at the top of your keyboard marked F1, F2 all the way to F12. F is short for function, and you can program these. Excel adds some programming to these keys. F4 is one of them. Notice what happens. I'm just going to select the cell reference. I'm going to press F4 and it puts $signs each side. If I press that F4 again, it does it next to the row reference. If I press F4 again, it puts it next to the column reference, and if I press F4 again, it removes them all. And if I keep pressing it, it goes in a cycle. All of them, row, column, none of them. All of them, row, column, none of them. So F4 is a really neat way of quickly doing that in case you can't be bothered or can't click in those areas. But that will work. And if I do all of them and I press enter, then when I pull this cell down, it will just keep saying 4 because this one is still looking at that cell there, exactly there. So that's locked onto that cell, and it doesn't matter if I pulled that way. This cell here, which is now all this way down and all this way across, still is looking at that one cell there. I can lock it in. This is called absolute addressing. It's different from the one we looked at over here, which is relative addressing, and this uses a mixture of relative and absolute. Here we've just used absolute addressing. I hope that's helped. In the next video, we're going to be looking back at formatting cells. See you then.